Hello everyone and welcome to the NPTEL course in Pharmacognosy and Phytochemistry. In the previous session, we learned about different lipid drugs containing fixed oil. In this session, we continue to see few more examples of drug containing lipids. In this session, we will be learning about few drugs such as Karanja oil, wool fat, beeswax and carnauba wax. To start with, let's discuss Karanja oil. Karanja oil is actually obtained from expression of kernels of Pongamia pinnata, or often referred to as Millettia pinnata plant, which belongs to the family Leguminosae. This plant is indigenous in the East Indies and grows in India as well as Philippines. It abundantly grows in Maharashtra and Karnataka, from where the Karanja oil is chiefly produced in India. If you see the tree is a medium sized plant bearing white flowers and green color pods. These pods often mature and turn into tan colored, which are slightly elliptic shape, flattened. Now when you open this, you see a kernel inside. These kernels are basically what are used for preparation of Karanja oil. So these kernels are tiny or maybe present as one or two per pod. What is done is these kernels are taken, thrashed from the trees. Once they fall down, they are beaten by either sticks or hammers to crush them open to expose the kernels. So you will see some kernels like this coming out. These kernels are collected. They have a thin papery coating, that is the kernel husk, and then a whitish color inner endosperm layer. Now this also contains the cotyledon. This is then pressed using mechanical expellers to obtain the Karanja oil. Karanja oil is little dark in color as compared to other oils, with a disagreeable odor and mostly considered to be non-edible. Now this Karanja contains numerous flavone derivatives, and if you see the structure, they contain majoritarily furanoflavone derivatives as well as flavones which are often associated with phenylpropanoids or furans derivative. Few of these flavonoids include Karanjin, which is the major compound, pinatin, Pongaglaberone, Pongamol, Pongapin, Kanjone. All of this have been isolated from the seeds and also make their way into the oil. If you prepare or if you try preparing soap from the crude oil, because of a special flavonoid called as isolongropin, it is appear or the soap takes a reddish coloration in presence of alkalis such as your KOH or sodium hydroxide. The major lipid fraction of it is full of oleanolic acid, which makes to about 71.3% of the lipids, and a small percentage of linoleic and other saturated fatty acids also are being found. Apart from this, few other pigments and unsaponifiable matter also makes up the composition of the Karanja oil. Now Karanja oil mostly, which is non expeller prepared, that is which is prepared using solvent extraction, goes into making of biodiesel, and that is the chief application. But apart from that, Karanja oil or Karanja, even leaves of the plants have been known for its insecticidal and pesticidal activity. The chief constituent of Karanja oil, Karanjin, is the compound which is known to possess the insecticidal activity. Now because of its antibacterial activity and emollient activity owing to oleic and linoleic acid. It is used in treatment of eczema, psoriasis, skin ulcers, dandruff, and also known to promote wound healing. So it's an oil often externally used for healing purpose and antimicrobial purpose, as well as given for skin ailments. And because of this, it is used in body oil, body salves, lotions, medicated soaps, hair oils, shampoos, and even garden sprays to get rid of insects and pests. In Ayurveda, Karanja oil carries a significance, that is, a small quantity of it mixed with other herbs is given as anthelmintic in healing of wound, ulcers, for itching, ascites formation or enlargement of spleen or abdomen, and in some cases when there are unwanted urinary discharges, mostly owing to the infections. It is also reported in traditional medicine to cure biliosinus, piles, leukoderma, and numerous skin diseases. The other lipid containing drug is we discuss as wool fat. Now wool fat is a pseudo fat, but because of its consistency and nature is referred to as fat. Wool fat is often referred to as hydrous wool fat, lanolin, or adapalene. Now this is something, as the name indicates, wool fat. It is actually the oleaginous layer which has been deposited on the surface of wool. So if you take our hair shaft, you know it has a peculiar sheen, and that sheen is due to presence of some oleaginous lipid or fatty mixture which is secreted by the sebaceous glands. Similarly, in your sheep, Ovis aries, which belongs to the Bovidae family, this oleaginous mixture which covers the wool is what goes into making the wool fat. So it contains almost 25 to 30% of water, and the remaining composition is made up of lipids. Now this is chiefly found in Australia, US and India, where sheep rearing is abundant. If you go to see the wool covering or the sheen of the wool, in terms of composition, we can divide it into three parts. The three parts include the wool sweat. Now what is sweat is when you see your sebaceous glands, they are going to secrete sebaceous and other fatty acids, as well as your cholesterol and cholesterol ethers. So this makes up majority of your wool sweat. So mostly chiefly what is here is your fatty acids. This fatty acids form soap with minerals secreted from the sweat like sodium, potassium. So you have salts of fatty acids which make up 31%. 32% is about earthy matter. So it's dirt, grime and filth which coats your wool. And then wool grease. Wool grease is the one which is rich in cholesterol and cholesterol esters, and that makes about 25% of the composition. So this is what your wool coverings are made up of, and from this we try to make your wool fat. Now how this is done is your wool is taken. Now it is washed with a specially curated detergent. Now this specially curated detergent will wash off everything that covers the wool. So it will kind of strip the wool of all its protective covering. You know that lipid layer is there to ensure that the wool stays dry and doesn't get moistened with water, similar like to our hair. So this special soap will remove everything out of it. Now when everything is removed, these washings are collected, and you will see that these washings separate to form an emulsion, and then there is a top layer. Now what is done is, to this emulsion and top layer you add acid. Generally sulfuric acid is added in this case, and the process is called as cracking. What it does is it kind of separates out the fatty acids and other oleaginous matter, and it starts floating out. Now this floating layer or the lipid layer can be separated either by centrifugation, or it can be separated by solvent extraction, that is dissolving in a organic solvent. This is done, but once this is done, it still contains certain dirt, grime or colored impurities which we don't want. In order to enrich the quality of that, it is bleached with certain bleaching agents, and what you get in the process is called as anhydrous lanolin. Now this is anhydrous because it's obtained from organic solvents, it has already separated water. So the good part of this is this anhydrous lanolin has the ability to absorb almost 30% of water. So this 30% water or 25 to 30% water is added, and what you get as a product is called as hydrous wool fat. This is something which is used in your cosmetics as well as pharmaceutical industry. If I have to describe the wool fat, it is whitish or yellowish white in color. It has a faint characteristic odor and a bland taste because it's lipid generally. Now this is a very sticky matter. You've seen this in the previous image. So this is how it forms. So it's yellowish, it's sticky and viscous. So if you take it and heat it, on heating it will separate out that 30% water and you will get two layers, and again on cooling you can just stir it and it will absorb back the water. Now this is practically insoluble in water when it is anhydrous. You need stirring, but once you stir it well, it will absorb almost 30% water. Now this is a good water absorbing cream, and it's a very good emollient for that purpose. Being lipid in nature, it is nicely soluble in chloroform, ether and certain organic solvents like benzene and carbon disulfide. Now coming to the chemical composition, as we saw, it contains fatty acids. Now this fatty acids form esters with alcohols, and most of these alcohols are cholesterol derivatives. So it can form esters with cholesterol or cholesterol like molecules. So if you see the composition, it's varied, containing thousands of different molecules, but the major ones include about 33 high molecular weight alcohols which form esters with about 36 high molecular weight fatty acid. And that is the reason I said it's a pseudo fat, because when we discuss your fixed oils and fats, we said that your fats are triglycerides, but if you see a wool fat, it is not triglyceride or it doesn't form a ester with glycerol. In fact, it forms ester with cholesterol, and that's the reason when you see cholesterol and isocholesterol esters, though it has a fat like consistency, it's still a ester derivative. Apart from that, the other acids include your carnaubic, oleic, myristic, palmitic, lanoseric as well as lanopalmitic acid, and in some cases it might even absorb and take into about 50% of its weight of water depending upon the composition. Now, if you see the aliphatic alcohols, it might contain cetyl, stearyl and carnaubyl as your aliphatic alcohols. Now, this is prone to rancidity, and hence you add what is called as butylated hydroxytoluene about 200 ppm as an antioxidant to prevent it from becoming rancid, because once it turns rancid, it smells bad and it cannot be used in the cosmetic industry. Now, if you see the standards, it has a melting point almost at body temperature. So at between 34 to 44, it's a liquidy or it has a molten consistency, and that makes it a very nice emollient for our creams because it's going to melt on your skin. Now acid value, if you see a pharmaceutical grade wool fat, the acid value should not be more than 1. Iodine value is about 18 to 36 in the mid range, and the saponification value is between 90 to 105. Its rancidity is a critical parameter, so we check for the peroxide values which should not be more than 20. Now how do you check for wool fat? Like we discussed, wool fat contains cholesterol and cholesterol derivatives, and one test what we can do for sterols is what is called as Lieberman-Bouchard test. So in this you can take your sample about 0.5 gram of anhydrous wool fat, dissolve it or disperse it in chloroform till it forms a nice clear solution, and add acetic anhydride. This helps in dehydrating and then you add H2SO4. So it forms sulfate or disulfate derivatives of sterols, and slowly with acetic anhydride, this disulfate derivatives produces a deep green coloration with sterols. So anything that contains sterols, especially your wool fat, will show a green coloration with your Lieberman-Bouchard reagent, which is your acetic anhydride and sulfuric acid. Now because of its property, it's used as water absorbable ointment and cream base. It uses water soluble creams, cosmetics, because it melts on your skin and is easily absorbable. Apart from that, few official products of wool fat include your wool fat BP, which is subjected to hydrogenation, and as a result it's more solid or more viscous, and wool alcohol, which is obtained by saponification of your crude lanolin. Now we go to the next one, and that's your beeswax. Beeswax comes from bees, and that's basically a purified wax obtained from honeycomb, that is the house of Apis mellifera, or what you call it as your bee, the Apidaceae family members. All of them form a honeycomb, and what you get is obtained from that honeycomb is honey as well as wax. Now this is generally sourced from France, Italy, Madagascar, in West Africa, Jamaica and India, where you will see abundant apiaries producing honey. This is one of a byproduct of honey producing industries. So beeswax is actually produced by glands which are located on the abdominal scales of the bees. They are secreted. The bees scrape them off onto their legs, especially the hind legs, and transfer it to the middle legs, and then they stick it. It is said that the fresh beeswax is almost colorless, but as it ages, matures, it develops a little yellowness, and that's why most of your natural beeswax have the typically yellow coloration. And it has a typically agreeable odor, and because of the sugars it has a nice honey like aroma. If you see the solubility, because of its high molecular weight, beeswax do not dissolve in water, but it's soluble in hot alcohol, ether, organic solvents chiefly like your chloroform, carbon tetrachloride, fixed oils as well as volatile oils. So if you want a stiffening agent for your creams, you might as well go for beeswax. Now how is it obtained? What is done is those beehives, the combs and cappings, once you are harvesting the honey, are all taken, and what is done is the honey is drained. Sometimes the honey is centrifuged, so that because of the centrifugal effect all the honey is gone, and what is left is just the hive combs, cappings, which is crushed. Now this crushed comb is kept in a gunny bag with some weight inside to let that gunny bag sink, and it's kept in boiling water. Now what happens is beeswax or lipids, as we know, they are lighter than water. So if you put something heavy in that gunny bag, the beeswax in boiling water will melt. Its melting point is close to 65 degrees Celsius, and what happens is it will ooze through that gunny sac, it will melt and reach the top. It will start floating. So once it boils and oozes out, it starts floating. You can stop the heat. As the water cools, all the layer that is floating, as the temperature drops below the melting point, that is below 65 degrees Celsius, your beeswax is going to solidify. So this debris initially is removed by scraping, and the slab of beeswax is taken. Now this beeswax, like I said, if it is yellowish in color, is subjected to bleaching to get a good quality pristine white beeswax. Now beeswax, in terms of its chemical composition, is made up of higher molecular weight compounds. Again, if you see, the chief compound or chief component of beeswax is myrcene, which is made up of myricil palmitate or often melisyl palmitate. If you see the structure here, it's basically an ester. You have your palmitic acid here, and you have your melisyl alcohol. Okay, so this is C30 and this is C16. So all in all, you have a C46 compound, which is a huge high molecular weight compound, and that's the reason it is solid. Apart from that, the other components of it are your melisyl stearate. So instead of C16, you will have stearate, which is C18. You have cerotic acid, which is, imagine, C26. So, and malicic acid, which is C30. So imagine you can have this as 18, you can have this as 26, you can have this as 30, and imagine how much the molecular weight, the highest would be even C60, which would be making it a very waxy compound. So it has all of this, and if you see specifically the Indian beeswax, it has low acid value. Now you can check the beeswax with what is called as clot test. Clot test involves saponifying your beeswax with caustic soda for about 10 minutes, and if there's no turbidity, your beeswax forms a clear dispersion or clear solution with that, you know that it's your genuine beeswax sample. Another thing what you can do or determine by titration is, we saw ester value and acid value. The ratio of ester values to acid value of your natural beeswax comes to somewhere between 3.3 to 4.3. Now because of its stiffness and hardness, it is used in ointments as hardening agent. If you want some stiff ointments, not the soft ones, you can use this. It is also component of certain water repellent plasters, polishes. Traditionally it has been used to make candles or even molds because of its high melting point. It is also found application in dental and electronic industries, but nowadays synthetic waxes are replacing it. Still, with the urge of natural, it makes its way in lipsticks, face creams, or even paraffin ointments. But despite this, it is adulterated with colophony or synthetic lipids such as had paraffin, stearic acid, and those obtained from other plants such as Japan wax, the artificial spermaceti, carnauba wax. But you can easily detect them by checking the solubility. You can do the clot test, or you can do the ratio, that is the ester is to acid ratio, and you will come to know whether it is genuine or not. The bleach pristine white beeswax is not fit for ophthalmic use. Now going to the next one, and this is carnauba wax. It is obtained from a palm tree called as Copernica prunifera and Copernica cerifera. Now this have like a palmate leaves, and if you see the leaf stems or the petioles part of it, they are covered with a waxy layer. This waxy layer or this plant is found in chiefly South American continent. So what is done is, the whole big leaves, like palmae have a big leaves. So these leaves are cut off, dried, and then threshed. Now what you can do is, you can either brush the wax from the surface, or you can beat it such that it separates out. So either by brushing or by beating, the waxy layer is separated and then put into a vessel to melt it. It's molten, whatever impurities are there, they are kind of strained off, and then this wax is poured into a mold to give you a yellowish green color wax, which is the carnauba wax. So far carnauba wax is known to be the wax which contains a huge or high molecular weight compounds. Again, as we know, the wax are esters. So this wax is chiefly an ester of melisyl cerotate. So you will see a cerotic acid, which is C26, and melisyl alcohol, which is your C30, same like your bees. So this again 46 carbon compound or ester is the major component of it. Apart from that, you will find in terms of its composition, 90% of the esters contain what are called as omega hydroxy acids. Okay, so they are there. Then you have your mono alcohols, mostly about C32 ones. You have your carnaubic and cerotic acid, which are C26 acids. You have malicyl cerotate, which is the ester, which is the primary component. Now, since majority of them are your esters of omega hydroxy acids and monoalcohols, some of them are also diols. So in this case, you can imagine, instead of this being a alcohol, you can imagine this as a diol, that is containing hydroxy on alpha as well as omega end. Now when you have diols, especially a C31, imagine this can be like as high as 30 carbon ones. Now this tend to form esters with two acids. So one part can form ester with cerotic acid. The second part is generally forming esters with your cinnamic acid and other derivatives. So in this carnauba wax, you will see monoesters also and diesters also due to presence of diols. Now this is one of the hardest wax with a melting point of about 82 to 86 degrees Celsius, and because of that, if you see numerous fruits, when you see nowadays people are applying paraffin wax on it, for especially on apples. Why? To increase the shelf life, to conserve the foods. This is something which has been authorized by European Union. You can see it has been given an E number, E903. So you can use it as a coating agent to increase the shelf life of food, and it is considered safe. In addition to that, it is used for making films. It is used to coat flavors so that they don't volatilize out or easily spread out. You can have, hydrophobic biodegradable packaging material. It has been used in cosmetic products, depilatories. Because of its stiffness, it is used in roll-ons and deodorant sticks. It is also used for tablet coating when you want a really hydrophobic coating. It is a part of polishes and automobile waxes. So these are few lipid examples that we come across in this chapter. For more reading, you can refer to these references, and thank you everyone for your patient listening.